Proportions, proportions, proportions. This is lesson 15.4, and we're talking similar solids. And really, this is just going back to, you guessed it, proportions, like this whole year has basically been about. So, it starts on page 694 if you're following along in your textbook. But it says at the beginning here, similar solids are solids that have the same shape and proportional corresponding dimensions. And we've done similar solids before, but we haven't gotten into their surface area and their volume like we are going to today. So here we go. It says identifying similar solids. So we're just talking about linear measurements here, which means they're just to the first degree. We're not squared units, not cubed units, meaning not area, not volume. Just a linear measure, a measure of a line, or a part of a line, of course. So here it says, check to see if corresponding dimensions are proportional. Well, we're trying to compare them to cylinder A to see which one of these two over here, B or C, is similar to A. So what I like to do is I put the smaller of the cylinders on top, so I remember. They didn't do that here. They put cylinder A on top here. So the height of A over the height of B, so we're just comparing these two right now, 4/3. And they wonder, is that equal to the radius of A over the radius of B, 6/5? So is 4/3 equal to 6/5? Is it a proportion? Well, let's do cross products here. 6 times 3, remember cross products across, is 18. 4 times 5 is 20. Since the cross products are not equal, this is not a proportion, not proportional. Let's try A and C. They put the height of A, 4, over the height of C, 5, 4/5. They put the radius of A, 6, over the radius of C, 7.5, 6/7.5. Doing cross products here, 6 times 5 is 30, 4 times 7.5 is 30. Because their cross products are equal, this is proportional. These are proportional. That means they are similar. They are the same shape and have proportional corresponding dimensions. So, in example 2, find the missing measure in similar solids. They're telling us these are indeed similar. So we know because they are telling us they're similar that their dimensions have to be proportional. So we can just set up a proportion. One of the dimensions will be a variable, and we can solve for that. So here they put the radius of x over the radius of y, so 5/7. The slant height of x over the slant height of y, so 13/L. We can do cross products here. 5 times L is 5L. 7 times 13 is 91. Divide both sides by 5, and we get L is 18.2 yards. 18.2 yards. Okay, so we can do the on-your-own problems down here. It says, in this first one, cylinder D has a radius, so for, this is number 1. Cylinder D, radius is 7.5 meters, and the height is 4.5 meters. Oops, starting to hover there a little bit. Which cylinder in example 1 is similar to cylinder D? So I'll take these dimensions and we'll take them back up here to example 1. And there were 3 cylinders here. Now, I'm going to try cylinder B, because if it were cylinder C, then it would also be similar to cylinder A, because these are 2 similar cylinders. So my guess, since they said it was only similar to which cylinder, singular, is it similar to, I'm guessing it's going to be B, but we'll give that a try just to double check here. So for cylinder B, we had a radius of 5 and a height of 3. So we'll set up a proportion. I'm going to put cylinder B on top because it's the smaller of the dimensions here. So I'll put the radius of B over the radius of D. And the height of B over the height of D. And now we're wondering, are these proportional? Okay, we're not saying they are, we're just wondering if they are. 7.5 times 3 would be 21, and 1.5, 22.5. And 5 times 4.5 would be 22.5, so 22.5. Oh yeah, 22.5. So yes, their cross products are equal. These are proportional. So for number 1, the answer is it is similar to cylinder B. Okay, so for number 1, cylinder D is similar to cylinder B. All right, number 2. The prisms at the right here are similar. Excellent. Find the missing width and length. Okay, well, they give us the height, so I'll just call this B and this L for big and little. So we'll put the big dimensions are the height equals 20. I'll call this the length because they have it labeled L over here for length. So the length equals 11 and the width equals 8. And for the little one, we have that the height is 8 and we need to find the length and the width. That's what we're trying to find. All right, so we can start our proportion, of course, with the height, because we know those. I like to put the smaller dimension on top. So 8 over 20 equals, and it'll be L over 11. Okay, height over height, length over length, and we get 20L equals 88. So divide by 20 on each side, and you get length equals 4 and 8/20, which is really 2/5. So 4 and 2/5 inches. For the width, we would start the same way. 8 over 20, that's the ratio we know because it's height over height. And I could use our lengths, but just in case I made an error there, we'll go back to the one that we for sure know, our height. And then we'll do the widths. So the smaller width on top, which is unknown, over 8, the one we know. So 8 over 20, height over height, W over 8, width over width. 8 times 8 is 64. W times 20 is 20W. Dividing both sides by 20 here, we get W equals 3 and 4/20, which is the same as 1/5 inches. So I'll go up here and put our answer for the length. We got 4 and 2/5, or that'd be same as 4 and 4/10 if you wanted to go decimal on us, 4.4 if you want. And for width, 3 and 1/5, which is the same as 3 and 2/10, or 3.2 inches going to decimal. So we knew they were similar, so we could use proportions to find the missing dimensions. So the second part of this idea here, we were talking linear measures, of course, so height, width, length, length, width, slant height is also linear, radius, diameter would be linear, height, radius, slant height again, Radius here is really the only dimension. Oh, you could do diameter, I guess. So all of those are just a line segment, okay? So since they're just a line segment and their units will just be, inches, yards, feet, just a linear measure, those are called linear measures. Surface areas of similar solids. When two solids are similar, the ratio of their surface area is equal to the ratio of their linear measures, but it's the square of it. The square of the ratio of their linear measures, which makes sense. We have to square their linear measures to get the ratio of their area measure. Well, the units help us out with that. The units for the area are squared, so we have to square the linear measures for them to be proportional. So let's take a look at what that means. Finding the surface area here. It tells us right off the bat, the pyramids are similar. Good, well, we don't have to worry about that. What is the surface area of Pyramid A? So we take the measures that we know for, and they're putting A on top, the height over height, 6 over 10, is equal to the surface area of Pyramid A, which we're trying to find, and they told us the surface area of Pyramid B, 600. So S over 600. But they couldn't just set them equal. They had to square the linear measures, 6 over 10. So we square those, which means multiply it by itself. So 6 times 6 is 36. 10 times 10 is 100. Well, now that we squared those two, 36 over 100, it just is equal to the surface area over the surface area. And in this case, surface area over 600. So we can just multiply the bottom by 6, multiply the top by 6, and we get 216. 36 times 6, 216. So the surface area of Pyramid A is 216, and it would be feet squared, okay? It tells us the feet, and it has to be squared because we are talking surface area. So now let's try some on our own. On your own. The solids are similar. Great, we already know that now. Find the surface area of the red solid. Round your answer to the nearest tenth. Ugh, I always don't like when it says that, but I guess things could be worse. So we're going to go, I'm going to go, for this one, I'm going to go red over blue because I like to put the small one on top and the big one on bottom. So width over width, 5 over 8. And that's the linear, so we're going to have to square that one. Equals the surface area of this one. We'll just use S. That's what they used up there. S over the surface area of the blue one, which is, it tells us 608. So here's our proportion. To solve that, we square this to get 25 over 64 equals S over 608. Well, ideally, 608 is evenly divisible by 64. Wouldn't that be nice? So 608 divided by 64 equals, it's close, 9.5. So we actually could do that, but let's not. So 25 times 608, so 25 times 608 equals 15,200, in case you didn't know that, 15,200. 64 times S is just 64S. Divide both sides by 64, and we get S equals 15,200 divided by 64, 237.5. Okay, so that worked out well. We don't have to round to the nearest tenth. It ends at the tenth place. And remember, this is area, so it'll be meters squared or square meters. For number 4, same type of problem. So we look here. We'll do their linear measures first. Small over big. So diameter over diameter. Now, we could have done radius over radius and cut this in half and cut that in half. We don't have to, though, because they have similar diameters, too. So 4 over 5, and we have to square that, equals the surface area of the blue, which is the top for us because it's the smaller of the two, 110, and the surface area of the red is what we're trying to find, so S. So now we square this to get 16 over 25 equals 110 over S. Now I do have zero hope that 110 is evenly divisible by 16. So we're just going to go straight into 110 times 25, which would be 2,750. 2,750 equals 16S. Divide both sides by 16. And it gives us S equals 171.875, which would round to 0.9. So 171.9. And I'm going to put a little squiggle in here because we rounded. It's now approximate and not equal. Approximately. And it would be 171.9 centimeters squared because it's area. Okay? So because we knew they were similar, we could use the square of their linear ratio equals their surface area ratio. There actually is one more key idea here, and it's the volume of similar solids. When two solids are similar, the ratio of their volumes is equal to the cube of the ratio of their linear measures. Well, that makes sense. Instead of squaring it to get area, we cube it to get volume. So a couple of on-your-own problems using working with the volumes here. Same type of problem that we were just doing with surface area, except we'll cube the linear measurements. So for number 5, we know these are similar, so go the small over the large again. 5 over 12, height over height, equals, we don't know the volume of this one, so I'll just use V over 228. So we're almost done here, except remember we have to cube this. Cube that. Okay? So now let's look. 5 times 5 is 25. Times 5 is 125. So 125 over 12 times 12 is 144. Times 12 is 1,728. So I've cubed this ratio to get 125 over 1728 equals volume over 288. Well, 1728 times V is just 1728V equals 125 times 288, which equals 36,000. Dividing both sides by 1728, divide by 1728, and we get volume equals 20.8333333, and we're supposed to round to the nearest tenth, so it would just be 0.8. This is volume, so our units will be cubed, and it was centimeters, so it'll be centimeters cubed. So 20.8 centimeters cubed is the volume of the small one. Now we have to do number 6. Same type of problem. We'll go this equals that. We already know this is going to have to be cubed. And we have 3 over 4. So 3 over 4, the width over the width. And then volume, that has to be cubed. Volume over the volume. So 9 is the one they give us. Volume is the one we're looking for of the big one. That's why I put it on the bottom. So we do have to cube this. Well, 3 times 3 is 9 times 3 is 27. So 27 over 4 times 4 is 16 times 4 is 64. So 3/4 times 3/4 times 3/4 is 27 over 64 equals 9 over V. So we can do 64 times 9, which is 576, equals 27 times V, 27V. Divide both sides by 27, and we're left with V equals 21.333333, which rounds to just 0.3. And that would be inches cubed because it's volume again. Excellent. Well, now that we have used similar solids to find out, first of all, using their dimensions to find out if they're similar, then knowing that they're similar, we could find missing dimensions, we could find missing surface area, and we could find missing volume. You can head over and do journal page 364 with ease, I am sure. Have a great day.